Alright, so we have these three triangles left to deal with, and then we'll look at the graphing review. So let's see. What I know is I have an 8 feet here and an 8 times the square root of 2 feet right there. So I'm going to say 8 radical 2 feet squared minus 8 feet squared is equal to d squared. So d is going to be 8 feet if you do the math. And so if you look at it, you really have a triangle that's a 45, 45, 90. So theta should be 45 degrees, but I'll show you that the tangent of theta is equal to 8 feet divided by 8 feet. The feet will cancel, and you'll have theta is equal to 1. I'm sorry, tangent is equal to 1, so theta is 45 degrees. Alright, this one was 14.25, 6.50, so I want to solve for the h side, so I said Pythagorean theorem again, 14.25 squared inches squared minus 6.50 inches squared is equal to h squared. And when I did that, I got h to be 12.68 or 12.7 inches. And then I said, well, the cosine of theta is 6.50 inches over 14.25 inches. My inches will cancel. So I did cosine, I divided 6.50 by 14.25, and then I did second function cosine and typed in that value that I got from my division, and theta was 62.9 inches. But they want it to the whole angle, so I'm going to say 63 inches. And over here I said 40 feet squared minus 20 feet squared is equal to f squared. Getting kind of messy here, let me clean it up a little bit. Is equal to f squared. So when I did that, I got f to come out with a value of 34.6 feet. So that's my side f. And then I said, well, the angle theta, let's see, I know the side opposite and the hypotenuse, so the sine of theta is 20 feet over 40 feet. The feet will cancel. 20 divided by 40 is a half. So the sine of theta is 0.5. So I said second function sine, and then I typed in 0.5, and it told me that theta was 30 degrees. Okay, I'm going to pause, and I'm going to pull up the graphing review and get that done for you. Okay, so now we're looking at this graphing review. And it says, below is a graph of a ball's motion. Which of the following gives the best interpretation of the ball's motion? My kids really struggle with recognizing that's a position versus time. So it started out at 5 meters, sat there, moved away from the 5 meters, and went down to 0 meters right there. Okay, this is a constant speed, because if you take the slope of that line, it's going to give you a constant value at every point along that line. So it moves along a flat surface, then it moves forward down a hill, and then finally stops. If it's going down a hill, it will accelerate, so that one won't work. The ball doesn't move at first, that's true. Then it moves forward down a hill, acceleration, and that says constant speed, so I'm not accelerating, so B won't work. The ball is moving at a constant velocity. That's true, it does move at a constant speed, but it's also at rest, so that one won't work. The ball doesn't move at first, that's true. Then it moves backwards and then finally stops. That's a negative slope, so that seems reasonable. Let's look at E though. The ball moves along a flat area. No, it's not moving at all, so that won't work. So I think that D is my best answer, because it completely describes what's going on. Alright, let's look at the next little set. Okay. So this one says, which graph would best depict the following scenario? A man starts at the origin, walks back slowly and steadily for 6 seconds, stands still for 6 seconds, then walks forward steadily about twice as fast as for 6 seconds. Note that these are velocity time graphs, okay? So if he starts at the origin, and he walks back slowly and steadily, so that tells me no acceleration. That tells me no acceleration. This is an acceleration because the speed is increasing. If you take the slope of that line, you'll get an acceleration. Here's another acceleration. Here's another acceleration. Here's another. Here's another. Here's another. Here's another. Here's another. Okay, no acceleration, no acceleration, no acceleration, no acceleration. So I got rid of choices A, B, C, and D because they all showed me an acceleration, and the description is that there is a steady motion. All right, so what I need to do then is I need to see that he starts at the origin and he walks back slowly. So walking back tells me that it's negative. Walking forward tells me that it's positive. So this would be walking forward, walking forward, walking forward. So let's see if this makes sense. So it has a negative velocity, and then he stops, and then he walks forward at about twice the speed. So that makes complete sense. So choice F is my best answer there. All right, let's scroll on down and go to the next setup. So the next setup says, for the same scenario as number 2, which position time graph best depicts the motion? So we're talking about that same man again. So it says that he starts at the origin, walks back slowly and steadily for 6 seconds, then he stands still. So I'm looking at a position time graph now. So if he walks steadily, then I should have a line that gives me a constant slope. Here he's not moving, here he's not moving. Here he's not moving, here he's not moving. Not moving, not moving, not moving, not moving. So I'm going to throw all those out because he doesn't even go anywhere. And that's not what it says to me. It says that he begins by starting at the origin and walking steadily. And he's going to walk back slowly. So backwards, remember, is negative. So that throws out C and A because those aren't negative until you get later on in the motion. So this would be your D. Here, he's walking steadily. Here he's walking steadily, but it's kind of odd because he goes back up to the origin. That's not what it says. It says he just stops, and then he goes back toward wherever. So B is my best answer there. All right, so let's roll on down to the next section. Okay, so it says a car is traveling along a road. Its velocity is recorded as a function of time, so there's a velocity versus time graph, and it's shown in the graph below. So he has a constant speed, here and here. He has a negative acceleration here and a positive acceleration here, and he has no speed there. So he's at rest. So that's what my graph tells me. Okay, so where do I see some acceleration? Well, I said I saw acceleration here and here. So if I look at my graph carefully, he accelerates between 3 and 8 seconds, which is choice C. And then it looks like he accelerates between 13 and 17 seconds, which is choice E. Okay, and let's move on to the next one. All right. So this one says, which of the following position time graphs would be consistent with the motion of the car in question 4? So in question 4, we said he was constant speed, and then we said he had a negative acceleration, so he was slowing down, and then he rested, and then he sped back up and had a constant speed. So this says he doesn't move at all, and that's not what my graph says and from question 4, so that won't work. Then it says for this one that he doesn't move, he doesn't move, he doesn't move, and he doesn't move. So the only one that makes any sense is here's my constant speed, here's my slowing down because my slope gets less and less, here's no slope, and then this is a constant speed again. Speeds up because that's what that curve tells me, he's accelerating, and then a constant speed. So I think choice A is my best. All right, then we look at the last one. It says a car is moving forward and applies the brakes, and that should be spelled B-R-A-K-E-S. So this is a positive velocity and a negative acceleration because he's losing velocity. So I want to look for a curve because there is some acceleration, so that pitches those answers out because none of them have curves. So I'm left with G, H, I, and J. So I'm going to scroll down and try to see those a little better. So we said A, B, C, D, E, and F were all not good because there's some acceleration and they don't show acceleration. So we're going to get rid of those. We're looking for a curve on a position versus time graph to show us acceleration. So here he starts out. Okay, he has to start from the origin, so I know that G and H can be pitched out. And here he has a high positive slope, and then it gets less and less positive. So he had a high initial positive velocity, which is what we said right there. And then because of that negative acceleration, it got to be less and less. This one has a negative slope, so that one won't work. So choice I is my best choice. All right, please study.